Hello, dear friend. This is Lu from China, Explorer Testing Company. Today, I would like to introduce XPS System and its application. The XPS system usually consists of the following components. First of all, as you know, XPS is a surface composition analysis technique. It needs to work in ultra-high vacuum condition. The second is XPS, where the incident source is X-ray. So how are X-ray produced? First of all, the electron, source, incident, metal, anode. As for commercial XPS, commonly used is alumina target. So the electron source, incident, alumina target excites the alumina characteristic X-ray. So after it's monochromatic, it becomes only alumina K-alpha X-ray incident on the sample surface. Excited photoelectrons are connected and retarded by input lens, go into energy analyzer, and finally arrive at detector. The detector detects the kinetic energy of the photoelectrons as well as their intensities. The data processing system converts kinetic energy into binding energy for the qualitative analysis of elements, chemical states, and the intensities used for semi-quantitative analysis. Commercial XPS systems such as Kratos, Thermo Fisher, and Specs, they mainly use static, large beam size X-ray source. Static source after monochromatic and incident on the sample surface. The excited photoelectrons arrive at the energy analyzer and finally connected by the detector. The energy analyzer is directly above the sample. You can see the takeoff angle of the photoelectron is 90 degrees. With large beam size with high power, the advantage of the system, the static incidence, is that its signal is relatively strong and the energy resolution is relatively high. As for PHI XPS, it uses scanning focused X-ray beam. So how does the X-ray source come out? Let's take a look at the video. First, a focused scanning electron beam incident on the surface of the alumina target. X-ray are excited and go into the monochromator and then incident on the sample surface. We can see that the X-ray source is a focused beam on the sample surface, and the scan frequency, beam size, as well as scanning area are strongly related to the electron source. So, what are the advantages of this design? When we need to analyze device or product, then I need to analyze multiple points. Or this kind of scanning focused X-ray source, it can connect secondary electron images for micro-area positioning. On this secondary electron imaging, we can define multiple analysis points, and the beam size can be continually adjusted according to the area size. The minimum beam size can be 10 micron, and the largest is about 100 microns. Once we located different micron areas for testing, the spectrum of the composition of multiple points can be acquired at the same time, and the difference of the composition can be quickly compared with each other. So the design expands the application fields. It can not only meet the analysis of a large area on raw material, or the analysis of different regions. Then it can also focus on multi-areas of devices or products, and then carry out a multi-area analysis. Also, can meet various failure analysis such as surface corrosion, surface contamination, and bonding failure, surface particle. So in this way, based on above introduction, so you can see XPS can handle both large area analysis and micro areas. It can meet different requirements or solve various problems in material fields. Main application, surface analysis. Also, XPS system can be extended by different techniques, such as a UPS or IPS can analyze band structures, such as valence band or conduction band, or by selecting an ion source for depth profiling for multi-area or multi-layer structures analysis, or passive layer, doping layer, diffusion, depth, etc. Thank you for today.